In this section called Hess's Law, we're going to apply the manipulations of delta H that we just learned in the last section. So Hess's law basically is summarized in this figure down here. This is the definition up here. That if I have a reaction that goes from A to D, and I want to know what that delta H is, but I can't safely do this reaction, or it takes a long time, whatever the reason may be, I can do a series of reactions instead and still get the overall reaction. But if I take A to B, and it has a delta H of 1, and then B to C, and it has a delta H of 2, and C to D, and have a delta H of 3, then this delta H up here is the sum of delta H1 plus delta H2 plus delta H3. So the way that we get these reactions of A to B, it may not be exactly how I want it to look like to add up to be this or not. So I may have to manipulate it by doing the manipulations of if I can multiply, then I do that. To do this, I have to look for two criteria. And I'm going to look in this order. So it's criteria 1 and then criteria 2. The criteria 1 is I'm looking at the known equation, and so it must be in the unknown equation, one of the compounds. So these are both for compounds. So the compound must be in the unknown equation, and it must not be in any of the other known equations. Okay, so it must be here, but it cannot be anywhere else, and I'll show you an example of that. So here's the first one. I have it symbolized up here. So it wants to know what is the heat of reaction at constant pressure for this reaction here. And I can tell it's for this reaction here because there is no delta H given. Okay, and it gives me 3 known reactions. Okay, so the first criteria was that it had to be in the unknown equation. So when I look at this, N2 is not up here. H2 is, so this one fits the first criteria, and NH3 fits the first criteria. Okay, so it must be in the unknown equation as the first criteria, and both of these things do that. Now, not usually am I going to have more than one to look at, because now I have to also clear the second criteria, and the second criteria is that it cannot be in any other equation. So if I look at hydrogen, hydrogen is here and here, so this does not fit the second criteria. However, I look at NH3, there's no NH3 in this equation, and there's no NH3 in this equation. So this is the only one that fits criteria 1 and 2. I didn't consider nitrogen because nitrogen did not even fit criteria number 1. So the question is, how do I make this? Now I'll do it like I did the previous, how to manipulate the equation, except for there I could look at any compound. Now I'm specifying which compound. But how do I make this NH3 look like that NH3? Okay, and so for NH3, okay, it's a product to a reactant. So I have to reverse it. And I'm going from a coefficient 2 to a coefficient 1. Okay, so I'm going to try to do, well, I don't know where I'm going to try to do this. Okay, because I need these to stack up. So I'm going to reverse this reaction, which means the product becomes a reactant, and I'm going to divide by 2. So I'm going to reverse and divide by 2. And you can do it as 2 different steps. I'm going to do it as 1. So 2 divided by 2 is 1, so I have NH3. That's the only product I have, so now I have the reaction arrow, because that now reversing it means it becomes a reactant. 1 N2, if I divide by 2, becomes 1/2 N2. And 3 divided by 2 becomes 3/2 H2. And the delta H becomes a positive 91.8 divided by 2, and that's going to give me 45.9 kilojoules. Okay, so that's equation number 1. Now I'm going to go to equation number 2. I'll go back to blue. Carbon does not exist up here, so I don't need to worry about carbon. Hydrogen does, and methane does. Okay? Now, I can cheat. I can tell you we've already eliminated hydrogen because of the fact that it was in other equations. So, therefore, that only leaves me the methane. Okay, so for methane, okay, again, it's, I'm going to erase that one. Okay, for methane, it's a reactant here and it's a product here. So I need to reverse. So I need to go from product to reactant. The coefficient here is 1 and the coefficient there is 1. So I'm going from 1 to 1. So there's no change there. So I need to make this line up. Okay, so to reverse it, that means that it's going to be CH4 goes to form carbon. I'm not going to worry about writing graphite, but carbon can come in multiple forms. That's why it specifies graphite. Plus 2 hydrogens. And the delta H is just going to simply become a positive 74.9 kilojoules. Okay. And for the last one, which is the hydrogen plus carbon plus nitrogen goes to HCN. Okay, we've already said hydrogen is up here in this equation. It's right there. And carbon is not. We've already seen it. Nitrogen's not. We've already seen it. And HCN is. So those two fit the first criteria. But on the same token, we've already eliminated hydrogen. So we're not going to use that one. So we're going to use HCN. So for HCN, okay, it's a product. It's a product. So no change there. I have a coefficient of 1 and a coefficient of 1, so it's 1 to 1. So no change. But I still need to write it down. Okay? So I wish I had these lined up better, but I don't. So I have 1/2 hydrogen plus carbon plus 1/2 nitrogen goes to form HCN, and my delta H stays 135.1. So I didn't make any change, so therefore I just rewrote it. Okay. Now this is a check. This doesn't have to be done, but I suggest doing it because it tells you if you did it right. I'm going to look at all my reactants, and the reaction arrow is like an equal sign. So same side, add, opposite side, subtract. Okay, so I have NH3, and I look, that's nitrogen, hydrogen, carbon, hydrogen, HCN. That's why it would be nice if my reaction arrows had lined up better. Okay, so there's nothing there, so I'm going to write it down here, NH3. Methane, nitrogen, hydrogen, carbon, hydrogen, HCN. No, there, HC4. Hydrogen, I've got 1/2 here and I've got 3/2 there. Okay, so 1/2 is smaller, so it goes away. 3/2 minus 1/2 is 2/2, which is the same thing as 1, so this becomes a coefficient of 1. Carbon, I've got 1 and I've got 1, so they just simply subtract. And I've got 1/2 nitrogen and 1/2 nitrogen, so they subtract away. And so that's all my reactants, so I'm left with, then the nitrogen went away, I have hydrogen. So I'm basically going to go through my products one at a time. If it's crossed out, then I don't write it down. If it isn't, oops, I forgot. I have 1 hydrogen here and 2 hydrogens there, so that's actually 3 hydrogens by adding these two together. And then the other thing that's not crossed out is HCN. Now, the order of these doesn't matter, but what I want to check is I've got 1 CH4, 1 CH4, 1 NH3, 1 NH3. So both of those are reactants because they're on the left-hand side. Then I've got the reaction arrow. And then I have 1 HCN, 1 HCN, and I've got 3 hydrogens, and I've got 2 hydrogens, and that should be 3 up here. If I look at this, this is not really balanced. I've got 4 plus 3 is 7. This really should have been a 3. I need to go back and correct that. I made a mistake. And so the 3 times 2 is 6 plus 1 gives me 7. So this was not balanced to start with. All right, and so then my delta H becomes 45.9 plus 74.9 plus the 135.1 to equal 255.9 kilojoules. And that is my final answer. So this has to be done. This over here doesn't have to be done, but like I said, it's a good check. If this doesn't match this up here, then I've made a mistake. Or in this case, I made a mistake in this one, but hopefully I won't do that for your test. All right, we'll come back and we will do another problem in the next video.